Okay, in this lesson we're going to discuss functions and their graphs. A lot of this was covered in the summer assignment, like piecewise functions or parent functions. This material will cover most of the material that was not necessarily in the summer assignment. And so to get started, our objective today is to identify the domain and the range of a function from an equation or a graph. So, okay, let's start off with a definition. And this will seem familiar from last year. A function is a rule that assigns elements in the domain to a unique, and when I say unique here I mean one. So it assigns elements in the range, or in the domain, to a unique element in the range. And a slightly easier or more transparent definition is that each input, so your domain or your x value, has only one output, so your range or your y value. And I just want to stop and say sorry about the honking. It's just getting a little bit loud outside of school right now. So to put a visual to this, oh, and one last thing. So you can have an output or a function with an output that has more than one input. It only goes one way. So an input can only have one output, but the opposite doesn't necessarily have to be true. So let's look at a visual example of a function. So you'll see here, I've got kind of two sets. There are no numbers, and that's kind of on purpose so that you can look at some examples without numbers. So if I've got a function, that means that in my domain, so if this circle is my domain, this one's my range, each of my inputs, so each of these points is an input, has exactly one output. So this one might go to this one. And like I said before, an output can have the same, an output can have more than one input. So it's okay if two of my same inputs go to the same output. That is still considered a function. It's just not okay if, like in this case, if I've got one input that goes to two different outputs, or one value in my domain that goes to two different values in my range. To put kind of a mathematical example to this, if I've got the function y equals x squared, and I know that y equals 9, what are my values of x that I can substitute into x here that will give me 9? So there might just be one number, or you might be able to think of a second. What are my values for x that will give me the output of 9? If you answered 3 and -3, you are correct. So I can plug in 3 squared will give me 9, and a -3 squared will also give me 9. So my inputs are 3 and -3, and my outputs are just 9. They'll both go to 9. And that's like this example up here where I've got two different inputs going to just one output. Okay. A few things that we're not going to cover in this lesson that you may want to review on your own include the vertical line test, how to identify a function from a set of points, and how to identify a function from a table. So if you have any questions about these three items, just let me know and we can review them together. But for the most part, you can either find them in your textbook or there's something that you just know how to do already. So before we move a little bit away from functions into graphs, let's look at some examples of real world function. So if I'm looking at a person's location as a function of time, person's location as a function of time, or my scenario 2, a person's height as a function of age. Before we get into this, I do want to talk just briefly about independent and dependent variables, which are going to come up a little bit more in word problems. So a dependent variable is determined by the independent variable, and your independent variable is always going to be your x value, or your x units. So dependent variable is determined, or it really depends on your independent variable. So for example, in a real world scenario, if I've got a sphere, so a 3D circle, the volume of that sphere, so the space inside it, is a function of the radius. So it depends on how long my radius is. If I've got a really large radius, then my volume is going to increase. If I've got a very small radius, my volume will decrease. So volume is a function of my radius, or of the length of my radius. So looking at those two real world examples. So let's look at that top one. A person's location as a function of time. I'm going to go through this one with you, and then you're going to be looking at the next one. So if I list out my location, so this is just one person, you can consider your schedule. At 7:15, what was your location? In my case, I was in the teacher's lounge. And then at 7:30, I moved over to my room, or room 330. Consider where you were at 8:30, at 9:30, at 10:30, and in each of these, your location might be changing. Considering each of these locations and your time, so your time is your input, and your location depends on your time, so this is going to be your output, or your dependent variable. Is this considered a function? Does each input have only one output? If you answered yes, this is a function, you are correct. So in this scenario, I'm never going to be both in my room and outside at the same time. I'm never going to really be in two places at once and truly be in two places at once. That just can't occur. So I will never have an input that has more than one output. So this is a function. If I look at the second example, let's see if I can, okay. So a person's height as a function of their time, or height as a function of time, sorry, height as a function of age, and this is just in general, so looking at multiple people. So take a moment and consider what is dependent on what. Is height dependent on age, or is age dependent on height? What is your dependent variable? If you answered that height is a function of age, you are correct. So in this case, height is dependent on your age, or on a person's age. So let's consider some examples. So my age is my input. The height is the output. So let's say that you are 17 years old. Consider what your height is. And now consider what the height of other 17-year-olds are. Is this a function? If you answered no, you are correct. This should not be a function, because if you consider, maybe you are 5'5", but there are plenty other 17-year-olds. Maybe there's a 6-foot tall 17-year-old. Maybe there's a 5'3" tall 17-year-old. You can have lots of different heights given different ages. So age or height is not a function of age in general. It might be if you're just looking at your height or one person's height as a function of their age, but looking at multiple people's height, I can't tell how tall someone is based off of their age. Okay, let's keep moving on. So we're going to now talk about how to notate the domain or the range of a function. We're going to look at two different options that you have. So you can either notate in interval notation or in inequality notation. but you should know how to use both options. And just as a quick reminder, when I'm talking about domain and range, domain is your possible x values, and range is your possible y values. So let's look at a couple examples of notation and then notate them ourselves. Okay. So if I've got these inequality or these number lines and I wanted to notate these using interval notation and using inequality notation, I've got a couple different options for how to do that. So if I'm using interval notation, just as a quick reminder, and maybe write this off to the side or in your margins, with interval notation, if I've got open circles on my number line, or if I do not want to include a value, then I use parentheses. If I've got a closed interval, then I use brackets. When I'm talking about infinity or negative infinity, I always have to use open parentheses. So open infinity and negative infinity are always open. And from there, this is pretty easy. So I'm just looking, we're going to go through a couple number line examples and then look at some graphs. I'm going to use interval notation to notate these. So if I'm looking at this first one, I have two open circles on my endpoints, and I have two endpoints, and my values are in between them. Since I'm looking at the values in between, I'm actually only going to have one interval. So it's going to go, my values are going from A to B. Since both of those values have open circles, I'm going to surround them with parentheses. So A gets an open parentheses, B also gets an open parentheses. This is a similar situation over here, interval notation-wise. So my values are in between A and B, so again, I'm only going to have one interval in between A and B. A is a closed circle, so I'm going to use brackets. And B is also a closed circle, so I'm going to use brackets again. When we're using inequality notation, we're simply going to consider this to be an inequality. So inequality. So in this case, I'm dealing with the variable x, or my values are x values. And my values, again, are in between A and B. So A and B are going to be in between, or are going to be at my endpoints of my inequality notation. So I'm looking at the values that are greater than A and less than B. So I'm going to throw x here in the middle. X has to be greater than A, so the larger endpoint is going to face x. And it has to be less than B. So the larger endpoint of my inequality has to face B. I'm not going to add a bar underneath because they can't equal A or B. This should be or feel pretty familiar to you. Take a moment and write your inequality notation for this interval. Okay, for this one you should have answered A is less than or equal to x, which is less than or equal to B. Let's look at a couple other problems. So I want you to give this one a try. What is the interval notation for this one? What is the inequality notation? Go ahead and give it a try. Okay, these should be your two answers. So you're going to, for interval notation, you'll have parentheses -3, 8, and then a bracket. And then for inequality notation, you're going to have -3 is less than x, which is less than or equal to -8. And so those are going to be your intervals. Let's look at this next one. So in this case, I've got the interval 3 all the way up into my large positives. When I'm going all the way up to my large positives, I'm going to consider my n value to be infinity. So if I'm using this in interval notation, I'm going from 3 to infinity. 3 is going to get a parentheses because I've got an open circle. And then as a quick reminder, parentheses always gets, or infinity always gets an open parentheses. So we're going to end this one as well with a parentheses. Go ahead and write your answer to, never mind. We're going to come back to this one. Lastly, an inequality notation. This should be pretty easy. I'm going to my values that are larger than 3, and this is in terms of x. So x is greater than 3. Or you can write it this way. X is greater than 3. Okay, go ahead and try this one. What's the interval notation? What's the inequality notation? Your two notations, so you're going to have parentheses, negative infinity, comma 3/2, close brackets. And then for inequalities, x is less than or equal to 3/2, or, 3/2 is greater than or equal to x. So let's look at these last two examples. So in this one, unlike the rest of these examples, there's a break in my number line. So there are no solutions actually in between a and b. Instead, I've got kind of two separate number lines. So I've got the values less than a, and then I've got the values greater than b. And so because there's a break, we're actually going to have a break in both of these notations. So I'm going to do interval notation first. Whenever there's a break, so there's a gap in my notation, I'm going to have a union in between my two intervals. And that union is just to show that these two are actually connected even though there's a gap between. So looking from left to right, I'm starting all the way over here at negative infinity, and then I'm going to my value a. Because a has an open circle, it's going to get parentheses. Then I've got this break, that's why I've got a union. You can always put a union wherever there's a break. And then I start up again at b. b gets a closed bracket because I've got a closed circle. And I'm going up to infinity, close with parentheses. For inequality notation, instead of having a union in between, I'm going to write and to separate my two inequalities. So looking at this first one, I've got x is less than a. X is less than a. And on this side, I've got x is greater than or equal to b. X is greater than or equal to b. There's no way that I can unite these other than by the words and or union. Okay, give this one a try. What is my notation going to look like? Where this applies to functions, we're going to talk about a few ways you can figure these problems out. So in this question, I'm asking you to state the domain and the range in interval notation, so not in inequality form, of y equals 4 minus x squared. So remember, domain is all of my possible x values, and range is all of my possible y values. We talked a little bit about this last year, and one of the easiest ways to consider this is to ask yourself the question, is there anything for x that I cannot, especially for domain, this works really well. Is there anything for x that I cannot substitute in? Anything for x that I cannot substitute in? And in this case, the answer is no. And we're actually going to look at a graph because that will help us with the range to see what my potential x and y values are. Okay, so we're going to graph this using our parent functions. I see an x squared, so I know that I'm going to have a parabola. I'm actually going to just reorder this so that I know what's in front of my x squared and how this 4 is affecting my graph. So I'm going to have y equals, I'm going to put my x squared out in front, and I have to bring over this negative. So negative x squared. And then my 4 is positive, so I'm going to add it to the end. So now I can clearly see that I've got a downward facing parabola thanks to my negative. And I'm just shifting that graph up 4. So 1, 2, 3, 4. And my graph is going to look something like this. So if I consider the domain and the range for this, there's no x value that I can plug in that'll make this function does not exist or undefined. So my domain, when that happens, is always going to be negative infinity to infinity in interval notation. My range for this function, so I need to consider which y values work and which y values will not exist. Go ahead and predict what you think it will be. In this graph, my graph stops at y equals 4. It doesn't go anywhere above it. So if I consider that, so my graph is anywhere from 4 all the way down to my negative y values, so all the way down to negative infinity. So my graph, I always start with interval notation at the smallest value. My graph is going to start at negative infinity, and then my largest possible y value is 4. Because I do have a solution, I have a point at 4, I'm going to have a bracket to close that parentheses, and that'll be my domain and range. Let's look at another example with this. So I want to state the domain and range, this time in inequality notation, of y equals 1 over x minus 2. I would highly recommend graphing this, just like we did up here with the parabola. Think about your parent functions. What does a negative 2 on the inside of your graph do? Take a moment and pause and graph that function. Okay, in the end, this is what your graph should look like. So I've moved my graph to the right 2 because I've got a negative on the inside. Just as a quick reminder, your parent function for y equals 1 over x. I'm going to have asymptotes at x equals 0 and at y equals 0. And so it'll shift just like my other parent functions do. So if I'm stating the domain for this graph in inequality notation, I want you to think about what are my x values? Which x values can I not have? Okay, so in this case, my x value just cannot equal 2. So it can be anything from negative infinity, and I'm going to just graph this on a number line below, and I'm going to have an open circle at 2 where it cannot equal 2. It can be anything all the way up to 2, and anything after 2. So in this case, I've got a little break in between my 2 pieces. I can't have anything equal to 2. So for my domain is going to be anything less than 2, so x is less than 2, and anything greater than 2. X is greater than 2. I just can't have x equal to 2. Let's consider the range of this function. What can my y values equal? Think about any asymptotes that you have. And in this case, I'm going to have a similar setup. As a reminder, I've got a horizontal asymptote at y equals 0. So in this case, my inequality, I'll turn it to the side. At 0, I'm going to have a hole. And anything up to 0 is fine, and anything after 0 is fine. Oops, sorry, you couldn't see that. So this inequality or set of inequalities is going to look very similar. X can be less than 0, and x can be greater than 0. X just cannot equal 0. And that's domain and range for different functions. Okay. Last piece of today's lesson, we're going to look at some even and odd functions. So to give you a definition, an even function is when you substitute in a negative x into your original function. So pretend we have the function f of x. and I substitute in this negative. When I simplify everything in my function, I should get out the same exact original function that I started with. All of my signs will stay the same. If that's true, I end up with the same function, then I have an even function. I have an odd function when I do the same thing, so I take my original function and I substitute in a negative x. And when I simplify everything, in an odd function, I'll have a negative on the outside, or I'll have all of my signs will change in my function. So we're going to look at one example, and then you're going to do a couple, and then we'll be done for today. So let's take a look at this. If I've got f of x equals x squared plus 4, and g of x equals the square root of x minus 1, take a minute and I want you to find g of f of x. So if I substituted in f of x into g of x, what will I be left with? Okay, this should be your answer. So I've now got the square root of x squared plus 4, and then I'm subtracting 1 from it on the outside. So now I want to know or answer the question, is this function even or odd? So in both of these cases, when I'm looking at even and odd functions, I want to substitute in a negative x and see what happens, and see if it's equal to f of x or if it's not equal to f of x. So looking at this, I want to see if it's even or odd, so I'm going to take f of, or g of, f of negative x. So wherever I have an x in this original function, I'm going to substitute in negative x. This will become equal to the square root of negative x squared plus 4, so my 4 doesn't have an x, so it stays exactly the same, minus 1. Same thing with my 1, it doesn't have an x, so it'll stay exactly the same. Now I'm going to simplify this. So negative x squared is just going to become x squared. So the square root of x squared plus 4 minus 1. And you'll notice that this is g of f of negative x, that this is the same exact thing as g of f of x. So I'm back up to my original function. When that happens, the function is automatically even. If I had had a negative out in front or a bunch of my signs had changed, then it would be an odd function. So I want you to give these 4 practice problems a try. Are these functions even or odd? Substitute in a negative x and see what you get out. That's the end of today's lesson. Sorry it ran a little bit long. Take some notes, take some good notes, and we'll work on the problem set tomorrow.